CCI, Crash Course Instrumentation presents episode number 71, VIRP Tables Made Simple. Standing credit. Thank you to Tony R. Coupalt and the open source community for the Mod L project. Hook. If tables ever made combination circuits feel harder, this is the calm, simple version. No drawings. No fancy visuals. Just words you can follow by ear. Roadmap. We will define the table, set up one small circuit in words, fill the table in 5 short steps, and end with 2 quick checks. Acronyms and terms we will use. VIRP means voltage, current, resistance, power. These are the 4 values we track for each part. KVL means Kirchhoff's voltage law. Around any closed path, voltage rises and drops add to 0. KCL means Kirchhoff's current law. At any connection point, currents in equal currents out. Equivalent resistance means a single resistance that behaves the same from the source's point of view. What the table is. 1 page with 4 columns: voltage, current, resistance, power. Each row is a thing in the circuit, either a real part or a temporary, equivalent block you create while simplifying. Our circuit in words, same one as EP70. There is a source then, resistor A in series with a parallel pair called B and C, that's it. A is in series with the block B in parallel with C. 5 simple steps to fill the table. 1. Add rows you will need. Make rows for A, B, and C. Add a row called RA for B in parallel with C. Add a row called RT for A in series with RA. 2. Write the resistance rules first. For RA, write parallel, smaller than either branch. For RT, write series, add them. If the numbers are unknown, the words are still useful because they guide your next move. 3. Use the source to finish the top row. If the source is a fixed voltage, that is the voltage in the RT row. Then current in RT is voltage divided by resistance. 4. Copy the right shared quantity as you expand. In series, the current is shared. Copy the RT current to row A and to row RA. In parallel, the voltage is shared. Copy the RA voltage to row B and to row C. Then use voltage equals current times resistance to fill any blank cells. 5. Compute power last. In each filled row, power is voltage times current. Power helps you spot mistakes. 2 short checks, so you trust your numbers. KVL check, voltage around the loop. Source rise equals the sum of drops across A and across the RA block. KCL check, currents at the split. Current entering the RA block equals the sum of the branch currents in B and C. Power tally. Power from the source equals the sum of the powers used by A, B, and C. Common mistakes and quick fixes. Only 1 R total row. Fix, always add rows for RA and RT, so you know where to copy current, series, and where to copy voltage, parallel. Copying the wrong thing. Fix, say it out loud, series shares current, parallel shares voltage. Then copy that one. Skipping power. Fix, multiply, voltage times current for every row at the end. If the source power does not match the sum of the loads, something is missing. Recap you can remember. Reduce. Obvious chunks and make rows for them. Use the source to get the RT row. Expand by copying the shared quantity, current in series, voltage in parallel. Check 1 loop and 1 node, tally power. If those checks pass, your table is right. Thanks to Tony R. Coupalt and the open source community. If this helped, like and subscribe to Crash Course Instrumentation. Next, episode 72 uses a tiny text readout from a simulator as a quick answer key. No graphics needed.